Okay class, so it's week number 7 and lecture number 40. We are going to start one of the most important topics of O-level mathematics, that is transformation. Most of the students thought that it is one of the difficult topics in O-level mathematics, but I don't think so that it is the most difficult topics. Now you should be thankful to the CIs because they have eliminated the difficult part, and that was share and stretch. These two difficult parts are eliminated by CIs in the last couple of years. So that is a good point, that you don't need to deal with the difficult portion of the topic transformation. Now, what is transformation? Transformation is a process in which we have an object that could be replaced by some operations. Under the influence of some operations, we got a image. That is a simple definition of a transformation, that it transforms a point known as object to a new point as an image. That is a basic definition of transformation, right? Now, in a transformation, we are going to deal with two types. One, we say isometric transformation, and the next one is non-isometric transformation. Now, the main difference between these two transformation and between these two type is, in isometric transformation, your shape and your size remains same before and after the transformation. But in non-isometric, the shape remains same, but the size, it does not remain same. So in a non-isometric transformation, there is a variation in size, but in an isometric transformation, there is no variation of shape or a size, right? So we are going to discuss some of the major or some of the basic types of a isometric transformation. In isometric transformation, we have three types of transformation. One is reflection, one is translation, and the last one is rotation. So there are three types of isometric transformation. It means that in these three transformations, we have the same shape and the same size, but it will be a different orientation. And when we talk about non-isometric transformation, so we are going to deal with enlargement. Now, by non-isometric transformation, we meant that in an enlargement, the shape remains same, but the size may vary. It may be larger or it may be smaller. So first we are going to start with the isometric transformation to give you the basic idea of the topic transformation. And in the isometric transformation, we are going to start with the reflection. So let's begin with reflection. Now, as you can perceive from the word reflection, so it must be identical in two ways. Like example, if I draw the alphabet V, so this V is identical across this line. So that means to define a reflection, the first thing we need is a line, and we call this line of reflection. What is the property of the line of reflection? That with respect to the line of reflection, the object on the left side and the image on the right side, they must be equal, as you can see in the example, right? So that is a line of reflection. Further, if I write alphabet A, right, and if I ask you to draw the line of reflection, I know that mostly of you draw this line in your mind. So this line A is a line of reflection, right? So with respect to the line of reflection, the point on the left side and the point on the left side and the point on the right side, they must be equal as compared with the line of reflection, right? The same concept you have been studied in the topic symmetry. So that is a line of reflection, distance must be same for the object and image with the line of reflection. Now in reflection we are going to study, or you can say that there are 4 cases, or you can say that 4 conditions of reflection. Now what are these 4 cases? The first one, reflection across x-axis. First one. Second, reflection across y-axis. Third one, reflection across line y is equals to x. Last one, reflection across line y is equals to minus x. Now these are the four most questions you can say in the topic reflection, or most repeated conditions. These 4 are, which you will observe in the past papers as well. I am not saying that only these are the 4 conditions of reflection. I am saying that these are the 4, you can say that the popular cases of the topic reflection. These 4 concepts, if you are clear in these 4 concepts, then you can reflect any point across any line or any axis, right? So let's suppose now I am just going to explain the topic before solving any question from the book. First we will understand the concepts in more depth. Now let's suppose on a piece of graph paper, I have a point, let's say coordinates are 1 and 2. I am saying that this point here is 1 and this one is 2. This is my x-axis and this is my y-axis. If I need to reflect the point across y-axis, now case is what? Reflect across y-axis. That means the y-axis will act as the line of symmetry. Now in your mind it will be clear to you that this point after reflection will go somewhere here, right? Because this line is the middle line of these 2 points. Now next thing you need to know that what are the coordinates of this point, the new point. So let's suppose you are moving from the point A towards the point A dash. You are moving. When you reach the point A, is there any change in your y value? So the answer must be no, because you are moving on the x direction only, so there is no change in y. That means A complement has the same y value, that is 2. Now we need to focus on the x value. In above examples, I told you that if this distance is 1, then this distance is also 1. So distance from the line of symmetry to the old point and to the new point, it must be same. In our case, this A was the old point, right? And you can say that this is our object, and this A dash is the new point and it is our image. Now when you reflect the object to the image across the line y-axis, so what is the distance here? The distance here is 1 unit. That means the distance with the image is also 1 unit. So its point is -1. Why -1? Because we are on the negative x-axis, right? So that is very basic example and a very easy example to understand the concept of a reflection, right? We are going to attempt some of more examples of the topic, same topic, reflection. So that's how we find the image point with the help of reflection. If you understand the example, very good. If you don't understand the example, no need to worry about, because we are going to do some more examples. So it's example number 2. Now suppose that on the graph I have a point and its coordinate is 2 and here its coordinate is 4. So that is my object. The point is A. The coordinates are 2, 4. That is my x-axis and that is my y-axis. I need to reflect the point A, the first part, across y-axis, the second part across x-axis. Starting with the first part, when you are reflecting the point across y-axis. So that means this point object, when we reflect it with the y-axis, so it will appear on the left side, right? That is a very common sense, that the reflection of A with this line, it will be flipped over here. So I am going to mention the point A dash here. I don't know the coordinates of A dash, so I need to work on that. The same example, if you are moving from point A towards A dash, so there is no change on the y value. The y is same here on this line. So the y coordinate is 4. Now we need to find the value of x coordinate. Now the distance from the line of reflection, that is the y-axis, to the point A is 2 units. If this distance is 2 units, that means this distance is also 2 units. But since we are moving on the negative x-axis, so it will be a -2, right? Alright. The second part I am going to attempt with the green pen. Now I am going to reflect the point A on the x-axis. That means when A is reflected towards the x-axis, so it will be flipped over here, right? So first thing is the graphical representation, that where this point should be, and I am going to label it with A double dash because single dash is already occupied. Now A double dash. If you are moving from A to A double dash, you are moving in y only, not in x. That means the x coordinate remains same and it is 2. Now we talk about the y coordinate. The distance from the line of reflection, this is the line of reflection, the x-axis, distance from the line of reflection to the object is 4 units, right? The y coordinate is 4. If the object is 4 units, then the image will also be at 4 unit. But since we are moving on the negative y, that is why it will be a -4, right? So I hope that this example is clear to you as compared to the first one. And if it is not clear, no need to worry about. We are going to attempt some more examples. Alright, okay. Now in this example there is a little modification. Now let's suppose we have a point here that is 6, that is 3, and you have a point here, it's A, having the coordinates of 6, 3. The question says reflect A 6, 3, and there are some parts A across y axis to the line y is equals to 0. Now the first part, if you reflect A across the y axis, so it will reflect here. The point is A dash. If you are moving from A to A dash, it means no change in the value of y. So y is 3 here. The distance here is 6 units. So this distance should also be 6 units. So it's 6. But we are moving on the negative side, so it's -6. Right? So it's -6. In the next part, I say reflect across the line y equal to 0. Now y equal to 0, it means that it's x-axis. So the question is same, but the way to ask the question is different. Now if you reflect A across the line y equal to 0 or x-axis, so this point it will be reflect over here, and that is A double dash No change in x because the movement is in y only, and the y coordinate it will be -3, right? Now I am going to add the third part here. If I say that reflect across the line x is equals to 4. Now the line is x equal to 4 in this case. At first you need to plot that line. So can you identify where should I plot the line x equal to 4? I am going to plot the line with the green pen so that it will be visible to you. X equal to 4 line lies here. That is the line x equal to 4. Now this point A, when you reflect across the line, I am going to highlight the new point with the red pen. So this point after the reflection with this line lies here, right? And I say that this point is A triple dash because that is the third reflection. A dash occupied, A double dash occupied. So now I am just picking A triple dash. Now when you are moving from A to A triple dash, the movement on the y axis is constant. That means the y distance is same, that is 3. Now we look closely about the x value. At this line the value of x is 4 as mentioned here. At A we have the x coordinate 6. So if I ask you what is the difference, so you will say that sir it's 2, right? 6 minus 4 it's 2. If this distance is 2, it means that this distance should also be 2, right? At this line the value of x is 4 and you are moving 2 units backward. So that means 4 minus 2 gives you the value of 2. That is the coordinate if you reflect it across the line x is equals to 4, right? I hope that it is clear to you. If these two parts are clear and the confusion is in the last part, then it is perfectly okay, because we are going to solve some more examples, some more questions. This topic is new, so you will take time to absorb this topic. No need to worry about. So moving on to another example, and in this example I will disclose a small technique that will make your question very easy. How? Just see in this question. You will solve the question in less than seconds. That technique works. Okay, so that is my y-axis and that is my x-axis. Suppose that you have a point here, its coordinate is x comma y. So we have a point and its coordinate is x comma y. At first we need to reflect it across y-axis, I can say, or I can say that in the line x equals to 0. It also means that y-axis. And you observe that in the last couple of questions, if you reflect this point, so it will become on the negative side, right? And the coordinates of this point, it will be y remains same, but the x is negative. So that means xy after reflection across the y-axis, it will be minus x comma y. Sorry, not 0, minus x comma y. So if you apply this technique in above questions, starting with, let's suppose this one, there is a point 2 comma 4, if you reflect it across y-axis, we know that the change is only in x. Y remains same and x is negative. So that is the answer. And you can see that our answer is also the same. So on the y-axis, xy swaps onto minus xy, right? So I hope that this is clear to you. Similarly, if the same point x comma y reflects on x-axis, right? By x-axis I mean that red pen for this question. This point will be shift over here, right? And I'll say that it's a double dash. Since no change in x value, so it remains same, and y will be negative. That means when you shift the point xy towards x-axis, so x remains same but y is negative y. Now to check this logic, we are going to attempt the point 6 comma 3. 6 comma 3, when you reflect it across x-axis, so x remains same but y changes its sign. So 6 comma minus 3, you can compare the answer, right? So these are the two shortcuts, two tips, two tricks that you can use whenever you have a case of reflection across the line y-axis or reflection across the line x-axis, right? Alright, if you have a problem regarding if there is a reflection not in the x or y axis but with a specific line, so I am going to tell you the method of this question. Okay, now inshallah in this example your concept will be crystal clear, inshallah. So that is my x-axis, that is my y-axis. I have a point here and its coordinate is, let's say this point is B and the coordinates are 7 comma 2. I need to reflect the point across the line x is equals to 1. That is the reflection line, and I need to reflect the point B to the line x equal to 1. That is my question. Now the first thing that you should visualize in your mind, just visualize this important thing. After the reflection, where should this point be visible to us? After reflection, B should be lie here, after reflection B should be lie here, or after reflection B should be lie here. So if your answer is this, congratulations, you have done 60% of the question, because that is the major portion. So I hope that all of you come up with the solution that B should be lie here after reflection. What are the coordinates? It is not important right now. Right now the important part is you should be visualize where the point should be reflected after the reflection. Once you got the point and once you are sure that the point lies here, now you need to work on the coordinates. The first thing, basic principle, if you are moving from this B to B dash, so your y coordinate is not changing. So half of the question we also done that the y coordinate is 2. Now the x coordinate, we need to find the difference. At the line, the value of x is 1. At the coordinate, the value of x is 7. So you need to find the difference. So the difference we have, it's 6, right? And why we had find the distance? Because if this distance is 6, That means this distance from the line of reflection should be equals to 6. Now you are at the line at the point 1. You are moving 6 steps backwards. So let's count 1. So you are at 0. Now you need to move 5 steps. So 1, 2, 3, 4, 5. So the value is 5, but we are moving on the negative x-axis, so this point is -5. I hope that now it is clear to you. I hope. And if it is not, no need to worry about. Trust me, you are going to learn. It is very easy. With the continue of the same example, let's suppose I make another line and I say the line, I'm going to attempt it with the green pen so that it is visible to you. Let's suppose this time the line lies here and its value is 6. Now can you identify when B is reflected with this line, where should it lie? So it will be lie here, right? The y coordinate remains same, that is 2. The difference here is 1 unit, so that means the difference here should also be 1 unit. You are standing at 6, 1 unit to the left, that means you are standing at 5. So that is the answer. I hope that it is clear to you. Now one thing, let's suppose I ask the question in a slight change manner. If I ask you that there is a point whose coordinate is 1, 2 and there is another point, it's point A and its point A dash, the coordinates are 5, 2, and you need to find the line of reflection. What is the line of reflection? So how you find the line of reflection? Keep in mind that line of reflection should be lying in between these two values. It is exactly the halfway. Still, can you find out the line of equation? Give it a try by yourself. जो भी समझ में आ रहा है try करो, and then compare your answer with mine answer. To find the line of reflection, we are going to find the middle value of these 2 points. And how we find the middle point? Very simple. You need to add these two, 1 plus 5, and just divide it by 2. So that is 3. That means this line has a value of x is equals to 3. Simple, right? It's very simple, because the line of reflection always lies at the midpoint, at the center. In all the above examples, you can witness that. Starting with, let's suppose example number 1, this one. It is 2, 4, distance is 2. That means this line here is the line of reflection. It lies exactly between these two. That is our major concept of the topic reflection, that the line of reflection always lies in the middle of the 2 points, and among those 2 points, 1 point is the object and 1 point is the image, right? So you can find the line of reflection by adding the 2 values and then just divide it by 2. So you will get the line of reflection. So I hope that all these things are clear to you. Keep in mind that we haven't covered the reflection across the line y is equals to x, or the reflection across the line y equal to minus x. I am going to cover these two in the next class. So in today's class, what I had told you, you need to revise it for the next class. So when we are going to start these two in next class, so it will be very easy for you, right? So see you in next class. Take care and Allah Hafiz.